My name is Bill. This talk is on permanent caching. The target audience is professional web developers comfortable with setting HTTP headers. By the end of this talk, you should understand how to reduce page loading times from 7.7 seconds down to 1.8 seconds using only caching changes and without serving stale content. The methods used to achieve this are the HTTP headers expires and cache control and the use of versioned URLs. The tools used in this presentation are the Chrome and the Chrome Developer tools, along with Fiddler 2 to simulate a high latency connection. We will begin by showing the difference between a low latency and high latency connection for an initial page loading time. We will start with the low latency connection initial page loading time. As you can see, the page loads in about 1 second on this low latency connection. The problem is that many users are not using a low latency connection, and so we will look at the effects of latency on the initial page loading time next. We will now look at high latency initial page loading time. As you can see, the page now takes significantly longer to load due to the higher latency connection. This latency imposes a penalty on how fast the browser and the server can communicate. This 200 millisecond latency that we're using here is more in line with what many of your users will be using on mobile devices. What we're seeing here is that this latency imposed a penalty on the page of about 13 seconds over what it took to load the page on a low latency connection. We will now cover the problem of the returning visitor. The problem is that we want to serve the user fresh content while still allowing the browser to cache content that hasn't changed yet. Most sites do this by having the browser re-request the content and the server sends a 304 not modified to indicate that the data has not changed. That way you only have the overhead of the connection, but you don't have the overhead of sending the data again. This works very well on a low latency connection, but it works very poorly on a high latency connection. We will now look at a low latency page reload. As you can see, on a low latency connection, the page takes about 1 second to load. This is pretty good. The problem is about half of the time is spent verifying all of the resources that we already have. This isn't a problem on a low latency connection, but it is a problem on a high latency connection. We will now look at a high latency page reload. As you can see, reloading the page takes about 8 seconds. Most of this time is just verifying all the resources that we already had. On a low latency connection, this verification only took about half a second. On a high latency connection, it adds up to about 7 seconds of the total time it takes to draw the page. The solution to this problem is permanent URL caching. Permanent caching is achieved through two parts. The first part is the use of the HTTP headers expires and cache control. The purpose of these two headers is to tell the browser that a resource is good until the expiration time is met. We set both of these numbers to be far out in the future so that the browser will not check back again for this resource. The second step is permanent URLs. What this means is that when the data changes, the URL to it changes also. This is useful for all resources that you serve on a page, including files, JavaScript, CSS, Flash, and images. The best way to do this is to put the version number inside the URL. This ensures that everything will properly cache this resource. If that is difficult for you to do, you can also put the version number in a query string. This is less desirable because under some circumstances, a browser will not cache these. We will now look at low latency page reload with permanent caching. With permanent URL caching, the page now loads in under half a second and no time is spent verifying resources that have not changed while still allowing us to instantly change the page. We will now look at high latency page reload with permanent caching. As you can see, the page now loads in about 1.7 seconds while still allowing us to instantly change the content and have it be reflected in the user's browser. This solves the problem. Thank you for watching. I hope you found this video useful. If you are using Zope, I have a product available on GitHub which implements the solutions shown in this video.